This information is taken from a real event where a Centaur H was surging when accelerating to load. I brought a borescope with me as there is always a good chance that the reason for surging could be damage to the compressor or turbine blades. I looked at the inlet and exit of the compressor. Any serious damage would be seen on the aft end of the compressor, because if one piece of metal breaks loose, it will break off more pieces and you will end up with a lot of small pieces at the end of a compressor. Another quick check is to look at the exhaust duct just after the turbine. Aluminium blades passing through the hot section will end up like spray paint on the internal part of the exhaust. No damage was found with the borescope, but it is always nice to take a look inside to ensure the surge has not done any damage. If you ever heard a compressor surging, you know it, as it is like a clap of thunder. It is a violent force that can do lots of damage. With nothing showing up in the borescope, the IGV was inspected, and the servo actuator feedback turnbuckle was discovered to be loose. The jam nut was backed off, probably by vibration. The IGV angle needed to be checked and adjusted to ensure it was within specification. The turbine was cranked over to develop the hydraulic pressure required to move the IGV. The plan was to command the IGV to various angles and then verify that the IGV actually went to that angle as measured by the IGV tool. The logic was modified to allow control of the IGV signal. The required counts were entered in the control to move the IGV to 12 degrees, but it moved the IGV to the full open position. The milliamp value was checked with a multimeter, and a reading of 30 milliamps was being displayed. I discovered that the signal was coming from a 0 to 50 milliamperes card, and the servo actuator was a 4 to 20 milliamperes actuator. The other output used by this card is a 0 to 50 milliamperes output to the fuel actuator, which is a 0 to 50 milliamperes actuator. I reconfigured that channel in the PLC to give us a 4 to 20 milliamperes output to the actuator, and then calibrated the IGV. I ran the unit and the IGV functioned correctly. Because of this configuration error, the IGV would open up 2.5 times quicker than it should, and would not be in the correct position for the rotor speed during the acceleration phase, between 80 and 97% NGP corrected speed. The Centaur turbine is relatively old technology and is not as efficient as the newer turbines such as the T70, Mars, etc. Because of this, there is a large surge margin and is less likely to surge. A retrofit had been done on several of these units, and the wrong channel configuration was on all of them. They had been operating without issue for over a year without incident, and if it were not for the linkage loosening, they would probably be still the same way. You would not get away with that on a Taurus 70, Mars or Titan, as the surge margin is much smaller.